So thank you everyone for joining us today. My name is Jorge Garcia, and today I'm joined by Rudy Hoffer to help us talk about the package generator in Fusion 360 Electronics. This is a feature that we released near the beginning of our journey with Fusion 360. But even to this day, there's lots of functionality that many users are not aware of, and that's one of the things we want to highlight throughout this webinar. So just to get started, feel free to put any questions through the chat, through the Q&A. Rudy will be keeping an eye on it, as well as I will as well. So if at any point you have a question, feel free to put it there. If we don't answer during the webinar, then at the end we'll go through some Q&A. So let's give you some brief introductions. Okay. Rudy, you want to tell us a little bit about yourself? Still muted.
Yeah, hi. My name is Rudy, and I've been involved in electronics for a long time. And I have a company called Arhover Electronics that specializes in making prototypes for large and small companies. And I've been doing that well over 30 years. I also was a professor at a Canadian college for 20 years. And I'm also very much involved with skills organizations for electronics and promoting electronics as a trade. And it's how I got involved with Jorge through World Skills, creating a test project for the World Skills competition in Kazan, Russia. So it's a bit about me.
Excellent. A little bit about myself. Been working with Eagle for now at this point a lot more than 10 years. I also have an engineering degree. Been working with electronics since I got out of college. Very happy to say that. Been working here pretty much almost since. I did have one other job before I came to Autodesk, but most of my career has been with Eagle, now Fusion 360 Electronics. So we look forward to talking about the package generator. I'm just going to show you a brief agenda of what we're going to be going over. We're going to talk about the package generator, what it does for you, how it works. Then we're going to highlight some terms that maybe if you've already played with the package generator, maybe you saw them and you just left them alone, didn't play with them. But we're going to go into them, specifically some of these specific IPC 7351 kind of land pattern designations and things like that. And then we're going to end by going over the pros and cons of the Edit 3D model workflow, since this is one that leverages the package generator very heavily. So with that said, I'm going to stop sharing my screen. So we're going to stop with the PowerPoint. And then we're going to go into Fusion. So bear with me 1 second. Okay. Perfect. Share now. Okay, can everyone see my screen? Can you see it, Rudy? Can you just give me a head nod?
Yep.
Yep. Okay, cool. Excellent. So this is Fusion 360. I'm sure many of you have already played with it. This is a library in Fusion 360. Fusion 360. And this is one that I use just to play around and show off different features and things like that. So today, most of our webinar is going to focus on the package generator. So if you're in a library, you're going to click over here on this icon. And this is the one that'll take you to the 3D model environment, which shows you the package generator. Now, this package generator is IPC 7351 compliant, and we'll be talking a little bit more about that standard shortly. And what you're going to see is that we already cover quite a big array of different types of components and different types of packaging for electronic components. And what's really nice about this is that besides the 3D model, you're also going to get a footprint. So the package generator will generate both the 3D model and the footprint. So those are two things we want to highlight first and foremost. Now, if you look at the different, well, let's say wizards available, the different footprint types that we support, we have some very specific ones, such as, BGAs, DFN2, DFN3, but you also have some more general or generic ones. And we're going to start talking about these. So if you go into something like Axial, you're going to notice that you have a drawing showing what the different parameters that you need to input are. So you can go to the component data sheet, enter the values, and that will generate the model for that part. But one thing that is sometimes not always immediately obvious is if you notice this component family drop down, if we switch to different things, the picture over here doesn't change, but the 3D model it generates does. So for example, if we're making a polarized capacitor, I'm going to click add, you're going to see that you get this type of footprint, right? It has a little notch in it indicating which side is the positive side or the negative side, depending on the part. If we go and say something like fuse, say update, you see that you get a glass fuse. So these are things that in these general wizards aren't immediately obvious. But if you make sure to set it up for the type of part you're making, then you'll see that you get a different model depending on what you're making. So something to keep in mind. You can see diode, you get the marker for where the cathode is, etc. And that's similar with the other generic parts. So if we look at something like, we go down over here to the radials, for example, and I put a polarized capacitor for this, you end up getting this model. And obviously you can change colors and all of that stuff. And then if you pick something like an inductor, for example, now you have a little dot for the inductor. So the parameters, as you can see, are shared. They're all the same for them. But depending on the component you pick, you'll be able to get a different model. So that's one of those things that isn't immediately obvious when you're using the package generator. Now, let's do something different here. Let's talk about something that's more common in SOIC. So it's in alphabetical order. You'll notice you have QFNs, etc. We're going to go into SOIC. Now, by default, it'll create a workable component. So all of these parameters by default give you something that's competent that you can play with. Now, obviously, if you have something like an 8-point surface, an 8-pin surface mount component, then you would have to go to the datasheet to get the parameters. So a datasheet such as, let me do a new share. Let's do, bear with me one second. Let's do this one. Okay, can you guys see the datasheet? Can you see the datasheet, Rudy? Or no, are you still seeing Fusion?
Still seeing Fusion. I don't see your data sheet yet.
Okay, so let's do the datasheet now then. Okay, how about now?
Yep, we can see it now.
Okay, so you'll see these parameters and then you input these into the package generator. Now, every company does their data sheet slightly different. So in this case, you don't have any ambiguity with the letters. They don't have the different parameters like in a table listed. But in some data sheets, you'll just see the picture and they'll be labeled with like A, B, C, D, whatever. In those situations, you have to be careful because if you go into here, these letters may not necessarily match whatever that manufacturer has chosen to use for their letters. So don't assume that they're the same. Don't assume that D in the package generator, capital D, is the same as the capital D that's in the manufacturer's data sheet. They necessarily aren't the same. So it's something to keep in mind. Now, if you go over here, you'll notice that you have controls over footprint, thermal, and manufacturing. What do these mean? So if we go into footprint, you'll notice that you can do some customizations. So if you choose to customize it, you can now enter these additional values to give you maybe slightly wider pads, adjust micro adjustments to the pitch, things like that. If you're happy with the default, you just uncheck that and leave it alone. With thermals, some components that have to dissipate large amounts of heat, you'll notice that underneath the main component body, there's actually like another pad. If the part you're working with has this, you're going to check this box and you're going to just define the dimensions of that pad. Going further though, if you have components like, let's say, are relatively large, let's say they're 10 by 10 millimeters, but have high density pin counts, with the thermal pad, you don't want all of that pad covered in solder paste. what ends up happening, and the bigger the pad is, generally the less solder paste you want on it. So you can make custom solder paste openings. So that way you get the correct amount of solder paste on the pad. So you have a lot of control here, and all of this gets taken into account in the footprint. So everything you're doing here, yes, it's part of the 3D model, but additionally, it will be put into the footprint when you make it. So at this point, I'm going to hit update to include this. Let's see what we get. Okay. If you look, there's a thermal pad. Okay. Let's go back into this one. The last tab, and Rudy, we're going to talk about this part now. You're going to notice a very simple tab. It just has density level, fabrication tolerance, placement tolerance. Now, fabrication and placement tolerances are pretty self-explanatory, but density level, you look at it and you're like most, nominal, and least. What does that mean? And actually, if you go into package, the silkscreen to body, you'll notice that it has the same max, nominal, and min. So what do these mean? Rudy, I think you have the 7351. Would you like to tell us a little bit about what these terms define according to the standard?
Yeah, sure. I wonder if I can share my screen.
Of course. Let me let you go for it.
One sec. And okay, I believe. Can you see do you see IPC 7351?
I do.
Perfect. Well, that's the standard. An IPC, I don't know if people know, but that's the Institute for Printed Circuits, and they have a lot of documents. It's an industry association, and they work with industry members to figure out the best way to make printed circuit boards. And they came up with a standard for surface mount design and LAN patterns. And
oh, you got muted, Rudy, for some reason. Double check.
am I unmuted now?
Now you're unmuted. You're good now.
Okay. I was using the space bar there. I guess you can't keep it pressed when you're on mute. As I was saying, there's 3 density levels: maximum, normal or nominal, and minimum. And the thing to remember, it's not maximum density, but rather it's maximum space used by the part, or maximum land used by the part. So think of it as in terms of most space used, a normal amount of space used, or least amount of space used. And it just defines how much space is allocated to those pads. Let me see if I can find the, they give you the chart here, and they'll even tell you how much the heel should use or how much the sides should use in their tables for that. And let's see if we can get a good graphic. It's at the end here, so I'll just zip through here real quick. There we go. So you can be, no, that's not it. Most, do we have it here? No. I might not get a graphic till the end. I think there were 50. There we go. Well, I think the graphic, whoa, okay. So you can see they talk about the level, the levels as well. Level A, B, and C talk about what's preferred, standard, or reduced size. And I apologize, I can't seem to find the graphic I'm looking for. But it is a graphic that just shows the amount of space used. Let me try courtyard, because courtyard is another term they use to define how much space is allocated. And you can see it, courtyard is the smallest rectangular area that provides the minimum electrical and mechanical clearance. And that plays a role in the density levels that you choose. And nope, I'm not going to find it. There we are. That's the graphic I was looking for. So you can see here when you choose your levels, you can choose how closely you want to pack your components in by choosing most, normal, or least amount when you're doing your IPC package generation. And I think, Jorge, I think you're going to go through an actual process of making a package using these IPC standards. So I'll stop sharing so you can take over. Or I think you can also control that too, can't you?
I can stop it. I'll do it. And then I'll go over here.
Okay.
Go back to Fusion. So going to kind of talking in practical terms, when in doubt, leave it nominal. if you're going to be doing a lot of like hand soldering or prototyping, you benefit from using most. So for example, look at these pads. I'm going to zoom in. Okay, and you see the green dashed line. That's the current pad definition. I'm going to switch it to most. I'm going to say update. What you're going to see is they're going to extend. You see they got much longer on both sides. So if you're doing lots of hand rework or you're prototyping, it benefits you to use most. Now, if you have a layout that has a large amount of components and is very dense, is very small, but with a high number of components, then you want each component to take the minimum amount of space possible. So in those cases, use least. And you're going to see that this pad is literally going to become almost like right at the pad, right at the pin, I'm sorry. So I'm going to go least, hit update, and you're going to see how tight that's going to get. You see it's like right there. So you can adjust the footprint depending on what your needs are. Now, similar to here, I'm going to put it back to nominal. In package, this is the courtyard kind of parameter. So you can do maximum, nominal, and minimum. Again, if you got room to play with, if you're doing prototypes, maximum is good. If you're going into final production and you need to save every square millimeter of PCB space because you have a lot of components to route, then you can go to minimum. In the package generator, we choose for the silkscreen to go maximum. So that way you always have, you know exactly how much space a component is going to take up on your PCB. And then for manufacturing, we have it nominal. Is how we use it. Okay. So at this point, we've played with the package generator. We're good. Now what we're going to do, is we're going to go ahead and save this. And we're going to get both the 3D model and the footprint in the library. So you notice we have a name already. And this again also comes from the standard. They have everything defined, how the name should be, all that stuff. So we're going to say finish. Okay, save. I do want to save. It's going to ask you, where do you want to save the model? So the library itself keeps a link to the model, but the model doesn't live in the library. So what we generally recommend is that you create a 3D models folder inside your libraries project and then save all the 3D models there. So that's what I'm going to do. I'm going to hit save. And now we're back at the library. Now what you're going to notice here in the library manager once it's ready is that we have a footprint. So if I go into footprints now, you'll see that it's there. And if I double click it, you'll see that it's perfect. Has
And the one thing, oh, sorry. I just want to say the one thing to notice is that name follows an IPC convention as well and describes in very precise terms what that footprint looks like.
Exactly. So if you know the standard, you can look at that name and you know exactly what it contains. So you'll notice it has the silk screen. Again, it encloses the entire body of the component. You have all of the pads properly numbered. You have that thermal pad in the middle, and it automatically creates that pin 1 designator for you. If we go and we turn on all the layers, let's just select them all and turn them all on. You're going to see that you get the cream mask that we specified, the stencil opening. Remember how we said the larger the pad, you don't want the entire thing covered with solder paste. So what we define the package generator is automatically created for us here, and you can see that. So really, if you're just new, if you're getting started, this is possibly the easiest way to create your own parts. If it's something that you can use a package generator, which most components conform to IPC standards, so a good 80% of components you'll be able to create with the package generator, then you can save yourself a lot of work. On top of that, you can reuse existing components. So that's going to make things easier. So at this point, we've shown the package generator. We just want to take a few moments to talk about the edit 3D model workflow. I'm going to go ahead and save this library. Always write something for the version. It's good to have a paper trail. Your 3D model, SOIC with thermal pad. Okay. And now I'm just going to open up some design. Okay, we're just going to open up a design. Just pick this one for fun. Nah. Let's open up the original. Nope. Nope. Okay, cool. So now if we look, you have your normal schematic, you have the 2D PCB. And I'm going to start off by saying this is a workflow that I don't personally encourage. You're generally better off going into the library and mapping models there. The reason, every time you use a component, the models automatically come with it. So you don't have to remap it. Every time you use it, it's already there. It's a one-time effort. If you're new, I know that effort can seem daunting, but you're better off just, swallowing that bitter pill, learning how to do it. In the long term, it'll be better for you. But if you're in a rush or you have somebody else's design and you just need to get some sort of 3D model done quickly, this is an option, what I'm about to show you. So you can right click on any component and you're going to see this option to add custom 3D model. So this is also useful if a component has a model that you don't like and you just need a one-off change, you can do it with this workflow as well. So you say add custom 3D model, tells you what you're about to do is not referenced in the library. The model will only be available in this document and it will only apply to the specific part you're doing. So this is not a group operation. If I have 300 of these op amps in the design, I have to do each one individually, which is another reason I don't promote this workflow. But it's good to be aware of it. So I'll say okay because I am intending to make this change. You'll see this is the pad, whatever you want to save it. I'm going to say save. Okay, I can then, if you go and you have a 3D model from, let's say, the manufacturer that you got from DigiKey or you got from somewhere else, you can just go in here and you can right click and say insert into current design. If you do that, it'll bring it in, make sure it's correct, right? You can say okay. Then when you're done, you say finish. And you'll know this one is different or incorrect because it has the double name and double value. I can always remove them, but just to show how this works. Say finish. Save. I'll put a doubled name and value. Say okay. And now that's it. Now this design has that model assigned to it. If I go to the 2D PCB, it'll tell you there's a new version of this. So it lets you know the change took effect. And then you can just go ahead and push the 3D model. Nope, I don't want to use the old one because I was playing and doing stuff like this. We'll give it a second. Okay, now it's in line. And if you look, there's a new model. And it actually only renders one of them, so you can't tell, but it's there. Okay.
I was going to say this is a nice way to add a 3D model to any part you've got just to see what it looks like. But as Jorge was saying, I find it a pain because it only works on that one part in that drawing. You really want to go to the library and update your devices there and put the model in there.
Correct. Yeah, that's the workflow we recommend. But we have found a lot of users, especially if they're new and they're just trying to get something done, they have kind of resorted to this workflow. So we thought, hey, we might as well make you aware of it if you're not already aware of it, so that it can get you out of a jam sometime. So that's what we wanted to discuss in this webinar. Thank you very much for joining us.